All right, so as I said yesterday, okay, we've been doing all of our stuff with, being able to identify reaction types, write them out in words, write them out in formula form and balance them and all of that stuff, okay? What we're headed to or starting today is predicting the products of a chemical reaction. So all I give you is the first half, okay? And this is where, as I said yesterday, knowing the patterns of our 5 reaction types is super important because they all start different. Okay? So let's say, for example, I gave you a reaction that looked like this, and I said lithium is reacting with nitrogen. Okay? Just looking at the reactants. Could you tell me what kind of reaction that is? It's a synthesis reaction. Only synthesis reactions start out with reactants that are 2 elements. Okay? So as long as we know the pattern, it's pretty easy to figure out what's going to happen on the other side. In a synthesis reaction, these 2 elements are going to do what? They're going to combine, right? And they're going to form a compound. Okay? So as long as I understand the pattern, it's not hard to figure out who's going to go with who on the product side of the reaction. Since this is a synthesis reaction, I know I'm going to form a compound made out of those 2 elements. Okay? So I'm just going to put them together. All I'm doing is following the pattern for a synthesis reaction. Now, what do I have to do with that compound since I just made an ionic compound? I have to drop and swap it. Okay, so I would say, all right, this is a -3, this is a +1, so Li3N, okay, is going to be my product. Okay, what do I have to do now? Balance it, right. Okay, so biggest number is 3, but if I go over here and put a 3 there, I'm going to have to erase it. How do I know that? Because nitrogen's a 2. Okay, so I know I'm going to have to just go back over here. So I'm going to balance the nitrogens first, even though it's not the biggest number. Okay, now the nitrogens are balanced. How many lithium do I have? 6. Okay, it isn't really a lot different than what we're already doing. If you know the patterns for the reactions, it's just a matter of, okay, so this is what would happen. Okay, as opposed to me giving you the whole reaction, you just have to put them together at the end. All right, so what about this one? What if I had, no, not carbon. Okay, well, let's do a carbon one. C5H12 plus O2. What kind of reaction would that be? Combustion. That's a combustion reaction. Okay, combustion reactions are the only reactions that start with a hydrocarbon reacting with oxygen. Okay, if I have carbon and hydrogen together in a compound and I have oxygen as the other reactant, it's a combustion reaction. What are always the products of a combustion reaction? CO2 and H2O, right? So as long as I, again, know the patterns, it's not hard to figure out what the products will be if I'm given the reactants. Okay, does it require you to know the patterns very well? Absolutely. That's something that you have to do, you have to go over and practice. And that's what we're going to do this week, okay, is just reinforce these patterns so that we can predict the products. All right, do we still have to balance this? Okay, do I need the rule of 2 on this one? Okay, so I got 5 carbons here, 5 there, 12 hydrogens. What needs to go here? 6. Okay, 5 times 2 is 10, plus 6 more is 16 oxygens in the products. 8 times 2 is 16. I'm done. Okay, so most of this is the same as what you've already been doing. Okay, all that's being required of you now is to recognize what kind of reaction it is and figure out who goes together. Okay, what about this one? What kind of reaction starts with an ionic compound and an element?
Single replacement.
It's a single replacement reaction. Okay? The replacement reactions are a little trickier, okay? But the pattern for a single replacement reaction is that this element has to swap out or replace the part of the ionic compound that it is like. Potassium is a metal, so it's going to swap out with the metal, with magnesium. Okay? So what that means is magnesium ends up alone, it gets swapped out, okay? And potassium replaces it. Okay? All I did was ask myself what happens in this kind of reaction, and then I make it happen. Okay? It's not guessing. Okay? It's just following the patterns until I've got what matters. Okay? All right. Is this reaction balanced? Okay, so 2 is my biggest number here, right? So I need to put a 2 there, and when I do that, it gives me how many potassium? 2. Okay, so I got to put a 2 here. Is it balanced now? I think so, right? 1 magnesium, 2 potassium, 2 nitrates, 2 nitrates. We're good. Okay. What about this one? It's a double replacement reaction. Okay, both of those compounds, are they both ionic? Okay, the only kind of reaction type that we know of that starts with 2 ionic compounds is a double replacement reaction. So, what happens in a double replacement reaction? The metals switch places. Okay, so now each one of the metals will be with a different nonmetal on the other side. So that means that potassium winds up with chlorine, and lead ends up with sulfur. Okay, now, did I just make 2 ionic compounds? Okay, so that's good because I have to, right? But what do I have to do with both of them? I have to drop and swap them. This one's okay because it's +1 and -1, so it's fine. Okay, and actually, so is this one. This one's +2 and -2. How did I know that lead was +2? Because it was +2 over here. Okay, that's one extra thing that you'll have to watch for if you got multivalent metals and special elements. They're little things that you have to watch for because you're building it yourself and you have to make sure you build it right. It's just little details, but okay, they're not terribly difficult. Is it balanced? Okay, 2 is the biggest number, so I think that's the only number we need, and then it's balanced. Okay? So I know I've only said this like a half a dozen times already in class, and we've only been here 10 minutes, but the patterns are what's important, okay? If you know the patterns for the reactions, you can always figure out who's gonna end up with who on the other side. Okay, what's the only reaction type we haven't done? We haven't done a decomposition reaction, okay? Now, decomposition reactions and single replacement reactions are probably the ones with the most nitpicky details. All right, so let's say I've got this. Okay, in a decomposition reaction, what's that compound going to do? Split, yeah. All right, so that's going to leave me with nitrogen and oxygen. What do I need to remember about both of them?
They're special.
They're both special. Those are the little details that can trip you up. Okay, it wouldn't have been hard for us to all figure out that, yeah, nitrogen and oxygen are going to be separated on the product side. What tricks people is they forget, oh, right, that's a special element, and so is that. Okay, because that changes how you would balance it in the end. Okay, so right now it's not balanced. Biggest number is 5. All right, so if I put a, let's see, what's the lowest common multiple of 5 and 2? 10, okay? So I would need to put a 5 here to get 10, and a 2 there. All right, now my oxygens are balanced. How many nitrogen do I have? 6, so what needs to go here? And I'm done. Okay? So you already have the skills necessary to do this. I just haven't asked you to do it yet. Okay? You know how to identify reaction types. You know how to balance reactions. You know you're supposed to look for special elements in a reaction. Okay? You know how to drop and swap ionic compounds. Okay? You guys have all the tools that you need to do these. It's just something you haven't been asked to do yet. Okay? Everybody kind of with me there? All right. Okay, so this little bit here, we'll just skip over this. This is the explanation for why we balance chemical reactions. We've been balancing chemical reactions for like 2 weeks already, so we already know how to do that. The reason we do it is because we have to obey the law of conservation of mass. Okay, I can't make more of something through a chemical reaction. I have to have the same amount of everything on both sides. Okay. All right, and balancing, we already know how to do that. Come on. Okay, so here's what I would like you to do. Let's just try 1 through 3 for now. Okay, write down 1 through 3. Predict the products of the reaction and balance it. Okay, now remember, here are the steps to do that. Step 1, identify the reaction type. Step 2, use the pattern to figure out who goes with who. Step 3, check for special elements, drop and swap ionic compounds. Step 4, balance. Okay, those are the things to do. Okay, so what kind of reaction is the first one? It's a synthesis reaction. All right, so in a synthesis reaction, these two things have to combine to form a single compound, and that compound will be an ionic compound. All right, so Ca with O. All right, since I built an ionic compound, I've got to drop and swap it. Oxygen's always a -2, calcium's always a +2, so it's already good the way I wrote it. Okay? Now what do I have to do? Now I have to balance it. Okay, so 2 over here for the oxygens. Now I have 2 oxygens on that side, but that gives me 2 calciums. So I've got to go back over here and put a 2 in front of the calcium, and now it's balanced. Okay, everybody all right with that one? All right, how many people have done the second? Okay, so what kind of reaction is the second? Decomposition. All right, so in a decomposition reaction, this compound has to split up into its 2 parts. That would be magnesium and sulfur. All right, now at this point, I got to ask myself a couple of questions about my products. Okay, just like I did in the first one, I said, what kind of compound is that? It's ionic. Okay, I have to drop and swap it. I didn't make any compounds here. I made 2 elements. What should I ask myself?
Is iron special?
Are any of them special? Okay, magnesium's not. Hurtful, but it's not. Okay, sulfur is. It's the most special. Okay, it comes as a what?
8.
All right. Now, if I forget that, is that going to cost me when I go to do the rest of this?
Yes.
Yeah, okay? If this is a 3-mark question and you forget that's an 8, you're going to get 1. Because you'll get a mark for identifying it basically as a decomposition reaction, but then your products are not right and your balancing won't be right either. Okay? So that's the thing that trips people up the most. Not the drop and swap. People get that just fine. Okay? They forget special elements more often than anything else, and that's what burns them on a question like this. Always check. As soon as you make the products, do I need to drop and swap anything? Do I have any special elements? Always the questions to ask. Okay, now I've got all of that done. I just need to balance. What needs to go right here?
8.
Right. Okay, that gives me 8 magnesiums, so I need an 8. Okay, how are we doing on number 3? Anybody want a little bit more time on 3? Okay, let's look at 3 then. What kind of reaction is that? That's a combustion reaction. It is only like the 5th or 6th time we've done this exact combustion reaction. It was your example back in your notes. Okay, so propane is reacting with oxygen. What are always the products of a combustion reaction? CO2 and water. Okay, so we're good with that. Now what do I have to do? To balance. Okay, do I need the rule of 2 for this one?
No.
Nope. Okay, so I'm going to put a 3 here. Okay, and 4 times 2 will give me 8 hydrogens. All right, now for the oxygens. 3 times 2 is 6, plus 4 more is 10. 5 times 2 is 10. Okay? Everybody okay with that? Is this making sense? All right, try the last one there. Okay, what kind of reaction is that?
Double replacement?
Yeah, they're both ionic compounds. Okay, so we got metal, non-metal, metal, non-metal, right? In a double replacement reaction, all that happens is that the metals swap partners. Okay, so we're gonna have, okay, hydrogen is gonna be with OH on this side, and sodium will be with chlorine on this side. Okay, this is, it's a double replacement reaction. It's also a neutralization reaction. This is an acid, and this is a base. Okay, whenever you mix an acid and a base together, you get water and a salt of some kind. In this case, actually table salt, okay, but not always. It's a salt, another ionic compound of some kind, right? So, is that reaction, do I need to drop and swap either of those? Well, I do, but they're already done, right? They're 1 and 1, 1 and 1, so we're good on that. Okay, is the reaction balanced?
Yes.
Yes, it is. Okay, so again, it's nothing you haven't done, at least piecemeal, okay, with other reactions. Just now you're having to build it yourself a little bit more than you did before. Okay. All right, I'm not going to do that flow chart. Okay, let's have you try these ones here, guys. Okay, do 5 to 8 for now, and I'll give you a little bit of time, and then we'll go through them. To be totally clear, these ones are a little tougher than the first 4 you got. Okay, there are little things to watch for in each of these reactions, like maybe multivalent metals are involved, and you'd have to figure out a charge. Okay, special elements being formed, things like that. So little things to watch out for that I didn't give you in the first 4. Okay. Okay, so what kind of reaction is number 5? It's a synthesis reaction. Okay, so that's going to make beryllium iodide, okay, Be with I. That's an ionic compound, so I've got to drop and swap. Okay, iodine's a -1, beryllium's a +2. Okay, so I get BeI2 for my product. Okay, does that make balancing this equation really easy? It's already balanced then, right? Okay, now let me tell you this. Understand how I'm going to test you on a quiz. Okay, this was pretty easy because everything was in order. What if, instead of writing it that way, I wrote it this way. Does that change anything? It absolutely does not. Okay, but on a quiz, I would write it that way to see if you remember that in an ionic compound, what comes first?
The metal.
The metal. Okay, you'd be surprised how many people I would catch with that. Just by changing the order, I'd get people who did this. Okay, not right. We don't list the nonmetal first in an ionic compound. It's those little things, right? You can be tested on a lot of different things in a single question. Okay, that doesn't just test reactions, prediction, and balancing. It also tests, do you remember how to write an ionic compound properly? Metal first, non-metal second. Okay. All right. How many people have done 6? Okay, let's have a look at 6. What kind of reaction are we looking at there?
Single replacement.
Okay. Okay. We got an element, potassium, reacting with an ionic compound. Okay. In this case, iron 2 oxide. How do I know?
Because oxygen has a charge on it too.
Right, I've got to look here, okay? And this is something that we have to do in a replacement reaction that involves a multivalent metal. We have to figure out what its charge is because we might have to drop and swap it on the other side. In this case, we don't. We don't have to drop and swap it on the other side, okay? Because it's going to wind up alone. But, okay, it's in a double replacement reaction, we would definitely need to know that. All right, so this is iron 2 oxide, okay? It's gonna swap out, okay? I almost always do this when I'm doing it myself. I just draw the things that are gonna switch, and then I go over here and go, okay, Fe winds up alone, potassium ends up with oxygen, not special, okay? Ionic, -2, +1, K2O. All right, now my products are done, okay? And that's like, honestly guys, I'm not just talking my way through it for your benefit. That's how I do them. I still talk my way through every single one of those. Not usually out loud, but my lips will move if you're watching me, okay? But I talk myself through each one so I don't miss a step. Okay? Now, looking at that, I've got potassium out of balance. There's 2 in the products. Now there's 2 in the reactants. Everything else is a 1, so we're good to leave it that way. Okay? All right, keep going there, guys. 7, 8, and 9. And 10. Okay. All right, let's look at the next one here. So for number 7, Justin, what kind of reaction is number 7?
Double replacement.
Double replacement. We got 2 ionic compounds there. Okay. So with our double replacement reaction, we know that the pattern says swap the metals so that they have new partners. All right. So that means that magnesium is going to end up with sulfate, okay, and copper is going to end up with chlorine. All right. Here's the multivalent metal thing I was talking about before. In order for me to drop and swap this compound here, I know chlorine's a -1, but copper can be a 1 or a 2, okay? So I've got to go back to the reactants because that's the only place where I can figure out what charge copper had to begin with, okay? The charge will never change. If it starts out on this side as a +2, it's going to be a +2 on the other side. It's not going to, you're not going to switch types of copper in a chemical reaction. Once you figure it out, it's that kind all the way through. All right. On this side, because sulfate's a -2, and there's 1 sulfate here, okay, I need to get 2 positive charges out of 1 copper, so that charge is 2+. Okay, so when I drop and swap, I'm going to get CuCl2 for that compound, and magnesium is a 2+, sulfate's a 2-, so that one's already good. If I want, I could put brackets around the sulfate, but I don't need to. All right, now I've got to balance this thing. Done. Okay, because it's already balanced, right? There's 1 copper, 2 chlorines, 2 chlorines, 1 magnesium, 1 magnesium, 1 sulfate, 1 sulfate. It's already balanced. Okay? Now, sometimes in the balancing, people get confused with the polyatomic ions. Okay? That's why. If that's you, and that's fine, okay? put brackets around every single polyatomic ion, whether it needs it or not, okay? It's the number outside the bracket that matters. If there's no number there, it's a 1, okay? It's probably the best way to avoid that problem kind of coming up and getting it. Okay, how many people have done 8? Okay, want more time on 8? I'll give you a little bit more time. All right, let's look at number 8 here. Evelyn, what kind of reaction is number 8?
Combustion.
It's a combustion reaction. Okay, so we got a hydrocarbon, it's reacting with oxygen. Products of a combustion reaction are always the same 2 things. They are?
Start alphabetically and the other 2.
Great, that's how we balance. What are the products?
Oh, carbon dioxide and water.
Carbon dioxide and water. Okay, and then we do need to balance alphabetically, and we'll need the rule of 2 because 4 is an even number. All right, so we'll start there. 2 times 4 is 8. Okay, 2 times 10 is 20. 10 times 2 is 20. Now I can do my oxygens. 8 times 2 is 16. 10 times 1 is 10. Okay, that's 26 oxygens. Pretty sure 13 times 2 is 26. Okay, everybody all right with that one? So the trick with combustion reactions is the balancing. The products are always the same. You just memorize. The products of a combustion reaction are CO2 and water, and then you just walk away from it. Okay? All right, I'm going to give you a couple more minutes on 9 and 10, and then we'll go through those. Okay, remember, special elements, multivalent metals, both. Okay? Okay, so just like I say, fill in the blanks. If you don't have the worksheet printed out, then you have a little copying to do. Okay, which, sorry. Okay, so other thing to remember is that you can check the keys. Okay, I did post the keys for all these worksheets in Google Classroom. So if you go into the classwork tab there, okay, and if you go into other items here under course materials, okay, you'll see reaction worksheets with keys. If you go into that file there, okay, every reaction worksheet that we have done, okay, is there as a key. Okay, so the one you're working on right now is right there. Okay, so you can check it as you go. Okay, recommendation: do 2 and then check. Do 2 more and then check. Don't do the whole sheet and then check. Okay, because it's possible you could be practicing a bad habit for the entire sheet and then go, oh crap, I've been doing the same thing wrong the whole time. Now you've practiced it. It'll be really hard to break it then. Okay, you're better off to do a couple, check. Do a couple, check. Okay, so in that situation, if you needed to quickly take out your phone to check, I'm okay with that. That's an educational purpose use of your phone. Okay, so if you need to check it every once in a while, I would say that would be okay, as long as you're not, Snapchatting or whatever. Okay, on F, this is something I told you a while back, but then we had a week off, so you probably forgot. Okay, anytime water is involved in either a single or double replacement reaction, it's often smart to do this. Write it like that instead. It's way easier then to track where the parts of it go on the other side. Okay, if we write it as H2O, then we're going, okay, the H's look balanced, but the O's, where did this other H come from? If we just write it like this, we know this OH came from here, and these H's came from here. Okay, which means that this isn't balanced right now, is it? All right, I've got 2 hydrogens over there. I only have 1 that's not part of OH over here, so I need to put a 2 there. Then that means I have 2 hydroxides, 2 OHs. So I need to put a 2 here. That would give me 2 sodiums. So I'd have to go back and put a 2 there. The only thing that's a 1 is the hydrogen. Okay? So in a replacement reaction, write water like it's an ionic compound. Okay? If we write it as H2O, it's molecular. Okay? If it's in a replacement reaction, it's kind of acting like it's ionic because water's weird. Right? So it's easier to track it that way. In a combustion reaction, write it as H2O, way easier to handle it that way. Okay? But in a replacement reaction, write it like it's ionic.
Should you do the same thing in G? Yeah, I would change this H2O here to HOH in G. Okay, it'll make it a lot easier to track where everything goes. Okay, because you start out with OH over there.